section 4.1, basic concepts of probability. Probability plays an important role or a central role in statistics, and it's part of a lot of statistical methods and hypothesis testing. So we're going to introduce in this chapter the basic concepts of probability, introduce the notation, the symbols, the basic definitions of probability rules, and so on. So because we will be using these concepts later on in chapter 8 when we talk about hypothesis testing. So I'll give you a basic statement here. There is 5% chance of rain tonight. Or today. Okay, there's 5% chance of rain today. This statement, or this here 5%, is considered a probability value. We have an event, and the event is rain today, and that event has a probability value, the probability of it occurring. So in mathematics, we say the following, guys. We say that I have an event we usually use a capital letter to name or label events. Event A, which is rain today, raining today. And this event has a probability value. So, and we use this notation, probability, or P of A. And this means the probability of event A occurring. And we usually write our probability values in decimal form or percent form. I can say 5%, or I can say the probability of A is 0.05. Both forms are acceptable, 5% or 0.05. Now, if I put a line on top of the name of the event, A bar, this means the probability of event A not occurring. Not happening. So in our example, A bar means no rain today. You see that? No rain. This is called the complement of A. A bar is the complement of A. And what is the probability of the complement of A bar, which is the probability of no rain? If the probability of rain is 5%, the probability of no rain is 100% minus 5, 95%, or 0.95. Right? So this is very important, where I'm introducing the notation for you guys. P of A, that means the probability of A occurring. P of A bar, the probability of event A not occurring. And you also need to know that the probability of A plus the probability of A bar, its complement, is always equal to 1 or 100%. Right? So probability of rain plus the probability of no rain must be equal to 1 or 100%. 0.05 plus 0.95, 1. So this is very important rule in probability. And you can use this rule to always find the probability of A bar. Probability of A bar is 1 minus the probability of A. Okay. Please note the following. The probability of any event occurring, the probability of event A occurring is always greater than or equal to 0 and less than or equal to 1. A probability value is never negative. It cannot be negative. You cannot say the probability of rain today is negative 5%. Doesn't mean anything. It doesn't make sense. You cannot say the probability of rain today is 120%. So the probability value of an event occurring is always between this range, from 0 to 1. Now, if the probability of an event is exactly equal to 0, then we can say that this event A is an impossible event. And if the probability of event A is exactly equal to 100%, then this event is called a certain event. Is a certain, for sure it is going to occur in the future. Okay, so for example, what is the probability of Thanksgiving on Thursday? Thanksgiving Day to be on Thursday. 100%. 1. Probability of what I'm trying to think of, an impossible event. What is it? The probability. Anything, guys, you can think of something impossible. Probability of I'll think of something else, you know. So the probability of any event is always within this range from 0 to 1. Okay. So now we talked about the notation, the symbols that we're using. Let's go ahead and apply this to this example. Okay. Consider the following sample data. All right, let's say I have these numbers in the sample. Let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I have these data values. I have this sample. And let's say I'm going to select one number at random. Okay, so let's say I put these numbers in a box, write on a small piece of paper, put these papers in the box, and then I close my eyes and draw and take one paper from the box. So I'm selecting one number at random. Find the probability of 4. What is the probability that I'm going to select 4, the number 4 from this set? Well, you can see that all these numbers are equally likely to be selected, right? Equal. Exactly the same size of paper, this, folded, everything exactly the same, all of them. So the probability of selecting 4 is what? This 4 is 1 out of how many numbers I have in the box? 1 out of 10. And that is equal to 0.1 or 10%. Right? What is the probability of selecting an even number? How many even numbers do I have? 0, 2, 4, 6, 8. 5 numbers in this set fit the description of even number. So what do I write? How do I find the probability of selecting an even number? Since I have 5 numbers are even out of 10, that's 0.5 or 50% chance. Okay. What about this event, the probability of this event, selecting a number that is at least 7? What do you guys think? How many numbers in the set falls under this event? or this description, at least 7. 7, 8, and 9, right? 3 numbers. So 3 out of 10. 30%. Probability of at most 4. The number that I get is at most 4. That means 4 or less. 0, 1, 2, 3, 4. So what is it? 5 out of 10, 50%. Yes. What is the probability of getting a 4 or 5? A 4 or 5? 2 out of 10. Which is 20%. Make sense? So selecting one number at random, because all of these numbers are equally likely to be selected, we're using this approach, right? We're counting the number of elements that falls in the event under the description of the event, and then dividing by the total number of outcomes. Right? So take the outcomes that fall into the event under the description of the event, divide by the total number of outcomes. Okay, so in general, probability of A. Number of outcomes of event A over the total number of outcomes. Guys, does that make sense? Are you with me? Okay, perfect. All right, so let me think. So we talked about the notation, the properties of probability. Okay. Example. Guys, suppose I have this sample data, letter grades. Suppose I have this set of letter grades, like sample of grades that I gave last semester. Okay. And again, I'm going to select one letter at random. What is the probability of selecting the letter A? Okay, so now notice the letters A, B, C, D, F are not equally likely to occur. Some letters are more than the others, so the probability of selecting an A is different from probability of selecting a B, because I have more A's in the set than B's, or more B's than A's, so the probability is different for each letter. So what is the probability of A in this case? How many A's do I have in this set? I have 2, but out of how many? 3, 6, 9, 12, 15. You see that? So 2 over, is it 14 or 15? 2, 4, oops. 3, 6, 7, 3, 6, 14, thank you. Two out of 14. I take this number and I multiply it by 100%, or first let's write it as a decimal first, and then we'll change it to percent. 2 over 14. 0.1428, and so on. If I want to round this to percent, I will say what? 14.3%. Right? I always round to 1/10 of a percent. 14.3%. What is the probability of selecting a B or a C? Here we're going to add how many B's and how many C's do we have? Let's see here. 1, 2, 3, 4, 5, 6, 7, 8. So I will say 7 out of 14, which is exactly 50%. So when you see the word or this, you're going to add. Okay, 50%. What is the probability of not selecting a C? Or in other words, in simple notation, C bar. What is the probability of that number that or letter I selected is not C? Is it an 8? 3, 4, 5, 6. Oh, I apologize, guys, not 7. 3, 6, 8. Please correct that. I made a mistake here. And 8 over 14 is 57.1%. Thank you, Karen. 57.1%, 8 out of 14. All right. What if I want to find the probability of this event of selecting a number, a letter, but that letter is not C. What do? I say 1 minus the probability of C. I'm finding the complement. And what is the probability of C? How many C's do I have? I have what? 1, 2, 3, 4. So 4 out of what? 14. 1 minus 4 out of 14, that is what? 10 out of 14. Okay. And 10 out of 14 is 71.4%. Any questions, guys, on this? 71.4, yeah. Okay. All right, guys, so you see how I'm calculating these probability of these events. In the first set that I showed you, all the numbers are repeated only same number of time equally. They are equally likely to occur. In the second set, the frequency of the letters is different, so the probability of these letters is different from each other because the frequency is different. Okay. One last point that I would like to discuss before we conclude this section. I want to show you guys this problem. Let me take a picture of this example here. So I want to explain, guys, this is real data. It says refer to the sample data. Okay, and these are results from drug tests of job applicants. Drug tests from job applicants. And if you look at the categories here, this category says that the subject or the individual uses drugs, but his test was positive. Positive test, I'm sorry, this uses drugs and positive test result, which means the test shows drug use, 45. So we have 45 applicants with a positive test, true positive. And this number here, this I have here 5 subjects that use drugs, but their test was negative. So this is what we call a false negative. Okay. And then the next row, the subject does not use drugs, right? But the test is positive. This is called a false positive. And of those subjects that do not use drugs, we have 480 that have negative test results, 480, which is a true negative because they do not use drugs. So this is summary of results from a drug test. Okay. Find the following. First, we're going to say, before we say find, I'm sorry, guys. One subject or one applicant is selected at random from this sample. Find the following. What is the probability that this applicant uses drugs? So what do I do? Oh, I look at the table. I look at the first row. That's the row where it talks about subjects uses drugs. How many, what is the total number here in the first row? 45 and 5, right? So I will say 45 plus 5 over the total. How many applicants or applicant results do I have here in this case? What is the total? So here I have 50 over 50 plus 25 plus 480. $555. Okay, I divide 50 by 555, and that gives me in percent form 9.0%. You see that? So I added all the numbers in the first row. Those are the people who use drugs. Some of them got positive test results, some got negative. 5 of them got added. I add all of them and divide by the total. That's the probability of selecting an applicant that uses drugs. Let's do another one. What is the probability of selecting one applicant and that applicant got negative test results? What do? I go to the second column, right? Negative test results. How many we got negative, regardless of whether it's false negative or true negative? 485 out of 555. $87.4%. One more. What is the probability that this person that is randomly selected has a false negative? How many false negatives? Applicants with false negative? Only 5 out of 555, right? That gives me 0.9%.